a price preference of 15% which was withdrawn. So and the domestic industry definitely looks for some other measures to compensate for the balance disadvantage arising out of withdrawal of the price preference. In fact, BHL have been in competitive market since 1977 or 76, when NTPC came into existence and their projects were financed by World Bank. We have been competing and getting the orders against competition. Almost 90% of the business was coming to BHEL. Another issue which is of concern to all the domestic manufacturers who have set up the facilities is the utilization of the capacity. One, of course, which is on account of coal, that not many projects are coming. Hopefully, it may not last for long, but other thing is the targets which are there, 88,000 for 12th plan, that itself, if orders are going to foreign suppliers also, what is left for the domestic suppliers will be able to cover only about 1/3 of the capacity which is going to be available. Although I feel at least that there is potential for much more of the projects and capacity to be utilized. These targets, of course, have been based on the extrapolation of the past demand, but when in the past the power has not been available to all the population of the country, then that cannot be the right benchmark for working out your future demand. If the power is available, like what we have seen in telecom sector, when the telephone service or mobile service at competitive rate had become available, more and more people have started using, and what we could not have imagined about 10 years back. Even a chai wala and a sabji wala is having a mobile today. So same way I feel for power, if the power is available in good quantity and reliable power, then it should be possible to increase the demand very significantly. Yeah. Another thing, what one of the speakers suggested, that Mr. Srivastava suggested, that when the old plants are becoming older, it may be a good option to consider replacing them instead of utilizing the scarce resources like water, land, and fuel on the old and less efficient plants. So that's all what I have to say.
Thank you very much. I think I'll stand there, and then one by one, somebody will make a presentation. We'll start. In the morning, we had about UMPP and the coal, but now is the real topic. Even if you have the coal and UMPP, but you don't have manufacturing facilities or the technologies, it's the same story. But anyway, in the last 5-7 years, with a lot of discussions were done on enhancing the capacities, because earlier we had one dominant player, and there was restriction on, not restriction, but there was not enough business for other people to come and put up their shops. When things were opened up, that there will be assured projects, there will be a planning documents were shown to the foreign investors and technology providers. Then there was a talk about manufacturers putting up their shops here, bringing the technology, whether it is to start with supercritical and then add on ultra-supercritical. If we go back to the technology, in the 60s we were having 30 megawatt, then went to 62.5 megawatt, then 110 megawatt, then 210 megawatt, then 250 megawatt, 500 megawatt. Then came the report from CA that, okay, if you have to increase our capacities, also go for higher efficiency and low carbon, we should go for a supercritical, and the units which are more viable in the supercritical, 660, 800, and ultra-supercritical could be 1000 megawatt. In consideration of that, the planning was being done. But then who would build the cat? The NTPC came forward that, okay, they'll come out with a plan of 10,000 megawatt, and let's start with the technologies coming from all the resources, whether it's from Japan, from Korea, from Russia, from Europe. Well, Europeans came. They were already there with BHL, but they came forward to set up the shops. They found the partners. Japanese came. All the major Japanese parties are here in India, and so the Koreans. In this respect, but you are fully dressed up. So I will like to, end here my initial talks, but we can continue to talk more on actual components, whether it's on BOP or BTG, and then we can have more questions from your side. So in this regard, I'll request Mr. Chandrasekhar to throw his light on this and say his words. Thank you.
That's the targets. How do you think in long run these manufacturing organizations will sustain?
I'm sorry, I couldn't get your question.
The question is, at one point of time we struggled to create the manufacturing facilities in the country, and now with the lot of, say, protected effect efforts of so many agencies, government and division, whatever you say, a lot of manufacturers are coming in and setting their shops. But in the long run, I don't find sustainability of these manufacturing organizations, considering the capacities that are there in the country today. So, say like 40,000 megawatt per annum is the capacity that is being generated, and then your overall target of 75,000 gigawatt for the whole plan. So, I see a mismatch in the, it's a sort of overcapacity situation.
Yeah, I understand your point. You see, let's go back to the basics. We are now producing around 870 billion units in the country. By 2017, we will require about 1,300, which is almost 70% more. By 2022, we are going to have 1,800 billion units. And when you convert that into the megawatts, we have to double up the current installed capacity, which means in next 10 years, 25 to 30,000 megawatt per year, we have to do it anyway. Now, it is not the manufacturing capacities which is a bottleneck today, neither the requirement. It is the other issues like as we discussed in the morning, or even the balance of plant. Then I always keep saying there are 5 M's are missing. So 1 M we have already on the manufacturing of the equipment. We are trying to reach that level where we can meet our requirements. The second M, the raw materials. Whether you take the CRGO, whether you take the boiler tubes, whether you take the plates of high thickness, we don't have that. So you're dependent on that. The third thing is the manpower. In 120 crore people, do we have enough manpower to put 40,000 megawatt per year? That is also to be. We may have a lot of population, but then we have to have that population which can be a skilled manpower who can execute these projects. Then machinery. Do we have that kind of construction machinery to handle this kind of level of construction to be done in every year? Then, of course, the final thing is the finance, money. So we'll have to also arrange the money. I mean, if somebody says we need 40 lakh crore, it is very good to listen by the politician. 40 lakh crore, their calculator and numbers start working like. So they will work on that basis. But who will put that money? Until as the other things, ingredients are put into place. So we'll have to see that. How many people who have put up the plants, even in the subcritical with Chinese machine, are able to get the money of the generation they have done and revenue? You know better. So if people cannot pay the old plants which are running, a depreciated plant, and yet they are going into losses, this is We have to correct that issue first.
Whatever is the current scenario is prevailing, is available to everybody, is known to everybody. What the point I wanted to highlight here is, are we entering into a phase of amnesty where we will be allowing power plants to amend their PPAs, or we'll be importing whatever technology so far low end or whatever is coming into India, we will allow them to come in?
No,
Is this what we are looking at?
No, I think I'll go back to when you talk about the PPAs. If you take the case of last 10 years,
Sir.
how much power increase tariffs have been there in the country? Were they right? Everything was going up, dollar was going up, steel was going up, labor cost was going up, but the end product, that remained same. So if that mismatch is brought to a zero level, no gap, then I think there will be no need to do revised PP every time. But you have to cover up that.
So, in other words, we, instead of correcting our past mistakes, we continue to make mistakes?
No,
Does that make to a solution?
I think I'll answer that way. If today people are getting 3 rupees or 3.5 rupees, average purchase price of every state is varying between 2.5 to 3.4. Now, if we really do proper with the type of technology we want to use, the current issues, and want to give return on to the investors on 15% without any risk of the regulator or the risk of not getting the payment, the 3 rupees 30 paisa is not the tariff, which should be to the consumer. Now, if you give them a right and they are being protected on their cost, irrespective of what are the fixed costs and what is the variable cost, but then the total thing which can be regulated and computation can be created. Now, there are issues which need to be understood between a developer, a transmitter, a distribution company, and a consumer. Now, it cannot be talked only in isolation of technology or in terms of the consumer.
Precisely.
So, in that sense, if you see a complete picture, then yes, I mean, I have put a transmission line as a sunk cost. So is the distribution wires are sunk cost. So if those people are not, then the government has monopoly in that. So if they are not considering properly the wheeling charges or the distribution losses, and then see in the end the distribution companies or utilities, everybody is going to losses. So then it's a problem. And then when they have no money, they will not pay to generators. And everybody is into back to same scale. So it cannot be talked about in isolation only generators, but a complete cycle.
I fully agree with you. But then at the same point in time, sir, if we only talk about generation primarily, because that is the only field out of the three which has gone ahead to some extent.
But electricity is one thing which cannot be stored. So if it was storable, I will fully agree with all the regulations, whatever they want to do.
There is one basic issue that Mr. Arora is asking. You know, PPAs are invariably entered by private utilities. So, invariably, government utilities are free to raise the tariff. Andhra Pradesh has raised their tariff between 7 and 37% in the last 5 years.
Very right, sir.
So, why the same relevance will not be there for private utility? Now, private utility has, you know, it is a double-edged sword. First word is they invest big money, then they do not know when they are halfway in their manufacturing, the whole blocks will take away. Or someone might have a PIL against them, their environmental clearance will be taken away. Then they will not be allowed to revise the targets. Who is going to invest 40 lakh crores in the company? That's why, you know, this Mr. Ashok Rana is president of the Association of Power Producers. He has put an estimate that already about 11,800 megawatt is the back burner. For this basic reason, they have stopped generation, and another 35,000 megawatt of the private utilities is expected to be not productive because of these conditions. So what are we talking about? We're talking about 25 gigawatt and 40 gigawatt. The fundamental issue is there is no protection with the private utility that he will get the right return for his investment. Now you look at the manufacturing cycle, you people 20,000 from BHL, 50,000 megawatt from the other 5 manufacturers, 35,000 megawatt. Perfect. Coal is there. 11th plan, we had a problem, there was no land and no environment. So whenever any private player would set up a power plant, there would be a local agitation that will not give you the land. Right? So 11th plan started, just when 12th plan started, we have the problem of CAG. Now they have this lurking fear that their coal blocks may be taken away any time. So all those who are invested, they are living with that fear. Those who are going to invest, the prospective investors, will think at least 100 times, because like in those days we used to have a lot of problems in civil construction because no welders, no fitters, no electricians would come to the sites because who would like to go to Blastpool, they would like to go to Abu Dhabi, but they would have much better relevance there. So all these fundamental factors are there. 12th plan, I don't know, we have unbelievable predictions of 1 lakh megawatt and 8 lakh megawatt by 2030. Looking at the current scenario, I don't know even what we achieved in 11th plan, we shut down halfway through this.
No, I fully agree with you, sir. At the same point in time, my basic question that while you are setting up a precedence of amending one, then you are in a way allowing others also based on that same principle to come in. Whereas this was one open window where probably a stricter measure could have been taken to filter those things out.
You have a point. If you do with one, you have to do with everybody. We live in a democracy and we have to
Precisely.
accept that. But we have to see from a logistic point of view also that yes, there were issues. We had a bidding and the developer had put those kind of conditions themselves. They were given option what is to be put in the variable, what is to be put in the fixed cost.
Right.
Now, he cannot have cake and eat too. But if the PP has to be amended, then he has to give his all books of accounts of what was the, and benchmarks for the capital cost and benchmark of the variable cost. Then it can be amended. But not as a blank, okay, I am making losses, you please help me. That is not good.
Some sort of regulation to that effect has to also come in place along with it.
I think the regulators are working on benchmarks. They'll find some way out.
Precisely, sir.
Dr. Dignitaries on the dais, dear delegates, I am Chandrasekhar, Assistant General Manager from BHL Tiruchirappalli plant. BHL having started 50 years back with a humble beginning of 30 megawatts. Today we have gone up to 800 megawatt capacity boilers we are building, and our capacity on those days started gradually from 750 to by 82 around 4,000 megawatt. Today we are having 20,000 megawatt is our capacity of the plant. So this is our journey. I just give a brief presentation about this. So this gives a scenario of the BHL's contribution to the power sector with almost 60% of the installed capacity comes from BHL. That is as on March 2012. And also generation-wise, virtually 3/4, 75% of the generation as on March 2012 is from BHL. This speaks about the volume of the business and also the quality of the equipments supplied by BHL. Virtually, it's a statement that every 3 hours out of 4 in India is supplied by power generated from BHL sets. This we take as a credit to us. So this in our boiler plant we can classify both subcritical and supercritical boilers. We have been doing subcritical boilers up to 2000. Up to from various capacities from 30 megawatt, 60, 120, 210, 250, 500, and of late 600 megawatt. This is our plan, various capacities. And supercritical boilers were introduced in late 2000s. We have introduced 660 and 800 as a standard rating. 660 came because 2000 by 3. That's what the concept. And 800 is what is the next set. So right now we are having in India both 660 as well as 800 sets, for which right now we are having a technical collaboration with Alstom, France. As far as our experience with Indian coals, we have got a wide experience of nearly half century with firing different types of coals. Even you take the last 500 megawatt boiler, introduced way back in 82. It is virtually crossed 25 years. That still it is running very fine. That is NTPC synchronically. So that speaks about the quality of the consistent performance of the BHL sets for the past 5 decades. And also, no other boiler manufacturers encountered such different types of coal. Coals in the other countries like US or in Australia or South Africa, they are higher in calorific value and lower in ash. Whereas in our case, it is ulta. Ours is higher in ash and lower in calorific value. This calls for designing of a milling system and all auxiliaries suitably for Indian coals. And also Indian coals are slightly the erosion potential is higher. Therefore, we are designing our boilers with a conservatively lower gas velocities. So these are all based on our experience, and the database of nearly out of 960 boilers we have from boiler side, 109 boilers have come from 500 megawatt category. 500 means 500, 520 by 600. More than around 150, 160 boilers are 210 to 50 category. So this forms the bulk of the power generation in these things. And again, based on the various feedbacks what we collect from the various units, we are continuously improving our product, and we are using latest state of technology software systems like PADO and intelligent food blowings. These things are added to our existing boilers, and right now the market is for 660 and 800 megawatt. Well, because as you are aware, once-through boilers for the benefit of others, it will result in a better increased cycle efficiency. I repeat, it is increased cycle efficiency. It has got nothing to do with boiler efficiency. Boiler efficiency is dictated by the property of the coal, and this efficiency increase in supercritical boiler is mainly due to the increased parameters from cycle. And also, when we increase the cycle parameter in supercritical boilers, we also correspondingly increase the temperature also, which we will see later. Because of this, we have a better efficiency, means lower fuel consumption, consequently lesser emission in CO2 NOx. And of course, operating costs will also come down. And because of this, we are going for higher steam parameters and higher pressures in the higher capacity ratings. So 660 megawatt is a new generation of 660 megawatt is the first standard set what we introduced. And after that is 800. Of course, in between, some of customers have opted for 700. We are giving 700 also. 700 megawatt is nothing but just an extension of 660 megawatt. So the basic funda is of 660 megawatt. So just to touch upon the basics, you are aware that any boiler operating about 221 pressure is called supercritical boilers. And this supercritical boiler, as you are aware, has got no drum, which is just got a huge reservoir-like thing where it can take up all the fluctuations in the load and other things. But whereas it is drum is not there, it has got a plus and minus. In the drum, we have a elaborate mechanism even to send chemicals for conditioning the water. Feed water conditioning can be done to some extent, and you can do the blowdown. You can open the blowdown valves and control the feed water chemistry. But such things is not possible in one-stroke boiler because there is no drum. Whatever water comes in, that has to go to superheater. If any amount of debris comes in, it is going to damage your turbine blade. So the water treatment plant has to be ultra clean. Okay, that is a plus. The other thing is the entire pressure is built by the boiler feed pump. In fact, boiler feed pump has to take care of the additional pressure that has to develop to force the entire water through the water wall circulation. Maybe around 40 kg more than with the conventional 500 megawatt boilers. Okay, and the concept is the mass flow through all the heat transfer circuits from economizer to superheater is same, whether from low load. And we at very low loads below 40%, it is not possible to maintain the once-through flow. Therefore, we are going for a small recirculation system. That's a concept. And the salient features of this boiler, these are all. This boiler is suitable for variable pressure operation. Single reheat up to 1000 megawatt, we can go for single reheat. Double reheat is not economical. And we are giving tilting tangential firing system, which is proven technology for the past half century. And our boilers will be dry bottom with balanced draft. Since number of mills happens to be more than 8, it is preferable always to locate on both sides of the boiler. This is our standard feature. And nowadays mills are coming with improved wear life. So the performance of the mill has improved compared with the late 70s. And all the fans are axial, including ID fans. Normally up to, in subcritical boilers, even now up to 500, 600, we give only radial fan because we are worried about the dust loading in the flue gas. But because of the stringent emission norms, we are having a very good ESP. We can think we are now giving axial fan for ID also. Virtually all FD, PA, ID, all the fans have been now converted into axial fans. This is the another improvement in the supercritical design. If you compare with the typical 500 megawatt, I will say 500 megawatt is a backbone because more than 100 sets are in operation, and the first set has crossed more than 25 years. So with this, with the, it is pressure wise it has gone from 170 atta to 250 atta. That means 80 gauge increase is there. From boiler side it is 179 to 56. Similarly, the superheater temperature also gone up from 540, 542, 568, 596. This is mainly the standardized superheater temperature of 568. Because of the low pressure, we can go up slightly higher temperature reheated to 596. Further, work is going on to increase the temperature beyond 600 degree. That work is going on. We are doing in the so-called ultra-supercritical boilers. We are working with NTPC and DGCAR to develop those things. But standard cycles, what we are offering is 250 bar, 568 and 596. This is a standard cycle what we give for a typical 600 megawatt boiler. And you can see the feed water coming. Sorry? I'll give the numbers. It is numbers coming. 660. This, the entire, the feed water comes through the economizer, then it goes to the water wall separator, superheater runs through. During normal operation, this part of the circuit is switched off. Below 40%, because of the intense heat flux felt in the water wall, we'll have to use a small recirculation. With this, a small circulation pump is also there. This is the characteristics of this once through boiler, because it is up to 30-35% by MCR. After that, this system is switched off. It is only in a once through mode. And the normal operating range is anyway 50% BMCR to 100%, so it doesn't matter. So major difference is the evaporator system, low load circulation and separator. Here these are the three major things that is differing here. And in the regular drum type boiler, you are aware this is the water wall and this is the economizer superheater. Here this is the you can see the separator. Drum is replaced by separator, which is a vertical thicken, but it has got no internals. It has got no internals, and it's just a dummy vessel, that's all, like a fractionating column. And this is a small circulating pump. This is used to circulate during the say up to 35% during that flow, because in that low load operation, the flow through the water wall is very low. Therefore, the heat flux that is felt on the water wall is so heavy, it is likely to damage. Even though we are not using carbon steel, we are using alloy steel, still it is not possible. Therefore, we will have to maintain certain amount of recirculation. That is called minimum once through load. It varies 30 to 40% BMCR. Generally, it is 30% BMCR. So, as I told you earlier, it has got because of this nature of this once through boiler design, stringent water quality is necessary, because once water entered cannot be controlled. And the control system is totally different. In the drum, you are aware, we have a 3-element control, and here it is totally different. And the low load circulation system is a new concept used in once through boilers. And this is, again, the spiral design is used. In regular drum type boilers, we are having as vertical walls. Here it is a spiral walls. Now, using the concept of spiral wall is number of walls are restricted. With a given number of vertical walls, the almost 50% can be reduced. So the number of parallel paths are reduced. That means there will be more mass flux density will be higher in this wall. Mass flux density will be improved with the use of spiral wall. Besides, since the same wall is going on all the four sides, there will be uniform heat absorption. So these are the two major plus points. That is why we are going for spiral. Besides, we will be using a smaller capacity, smaller diameter tubes. Not we are using 2-inch tubes, what we are in 500 megawatts, we will be going for still lesser than this. This is still to have a better mass flux density. And obviously all these things leads to a higher pressure drop in evaporator circuit. That is inevitable. That has to be borne by the feed water pump. But compared with the gain what you are getting, that is acceptable. Well, but again this, because of the high pressure, all the components have to be sized from for supercritical boiler. And the emerging trend is, as per the government of India norms, it is all the upcoming plants are going to be only supercritical, because they have an advantage or preference in coal allocation. So most of the utilities are switching over to supercritical, unless extension units are there. Otherwise, it is all the units that are going to come in the years are only supercritical. And as far as the manufacturing capabilities are, we have BHL Trichy, we have sent our people to abroad and we have trained, and we have similarly our Ardwar units have trained for turbine. And with this, we are ready to generate manufacture the components. And we have manufactured the components. I'll show some of the slides on what we have manufactured. And the manufacturing of this supercritical boiler, when compared to subcritical boilers, it is only in the evaporator system, because your fans or ESP, air heater, these are all, doesn't matter whether it is subcritical or supercritical. Gas side performance is not at all affected. Steam side, that too, in evaporator side alone, there is a change. So there the components are spiral valve, burner panel, sofa panel, that is separate overfire air, and separator and collecting vessels. These are the things we have already established manufacturing capable facilities at our Tiruchirappalli plant. With this, we are having to manufacture boilers up to 20,000 megawatt. And right now, recently, we have commissioned a new plant in Thirumayam that is about 80 kilometers down south from Tiruchirappalli, that is to cater to the piping requirements. So, main superheater, reheater, water valves are made in Trichy, and all the auxiliaries like fan, ESPs, electrostatic precipitators are made at our Ranipet plant. Then pipings are made piping center with a new additional plant facility at Thirumayam. In addition to our mills are manufactured at Hyderabad division. So all the things are covered like this. This is a typical separator. When you talk about a 500 megawatt boiler, you are aware it's about 225 tons drum. It's a huge component, thick walled one. But here it is a small. It will be a vertical like thing, but only thing is number of separators may vary 2 to 4 depending upon the size. Generally it may be 4 separators if you take a 660 megawatt. These 4 separators are collected in a common collecting vessel, which is then again going to the circulating system for startup purposes. This is a typical circulating, this is a typical header, separator manufactured at Tiruchirappalli plant for bar. This is, you see the complications of the burner panel, because these are multi-dimensional. You see all the XYs, that so much complex, because it's a spiral wall. Because of the spiral wall, there is some difficulty in manufacturing. It is not so easy, but it's a part of the technology. We have got the backup, and this is a panel, how it looks like. You see how complicated the bends are there. When you compare with a regular vertical wall, you'll be really amazed by the number of bends coming in all 3 different planes. Anything goes wrong, we are in out. So very precise machining and coordination is required to manufacture this. And we have succeeded and we have manufactured this. And this is again, you can see the spiral wall wind box assembly. This is what is where you're going to, how complicated is the wind box. When you compare, you are aware of most of the people with the vertical wall. You see the complete, but yes, these are all difficulties while doing manufacturing. Once it goes into operation, yes, you are going to reaping the benefit of spiral wall design. You see the spiral wall by itself, it cannot be hung from the top because it cannot be supported. Therefore, we are from here through that fingers, it is transferred to vertical wall, and from then it is taken. There, that is the, you can see the fingers. Can you? Is it fingers visible? No. That through the fingers we are transferring the load. And this is a typical vertical wall, spiral wall panel manufactured at phase 2. We have introduced phase 2 facility in the past 2 years back. This has been commissioned recently. This is a typical spiral wall manufacturing, how it is done. This is a brand new facility at Trichy. And this is again a sofa. This is and as you are aware, tangential firing system by itself is low NOx when compared with the wall firing. Obviously, that is added advantage. But in addition to that, we are right now we are having environmental norms of 260 grams per gigajoule as the NOx limitation. Therefore, we have overfire air compartments, integral overfire air compartment, which is a standard feature in all our subcritical boiler also. But here in separate overfire air assembly we are given, this is still a part of the air is given above the wind box. This is called separate overfire air. This will be further reduce the NOx to still lower level. So to summarize, we have observed the technology for this 660 to 800 megawatt from our collaborator, and we can offer design variants to various, whether it is 100% Indian coal or 100% imported coal or any combination thereof. If you say take NTPC bar, it has been designed for 100% Indian coal, and we have cases where we have got like Bara, where we could have 70% imported and 30% Indian, 70% Indian, 30% imported coal. And as you are aware, as per the Government of India Gazette, all the upcoming new plants are to be designed for a 30% imported coal as a basic requirement. That also we comply with this. Right now we have virtually 18 supercritical boilers are being executed at various stage. The first one is going to be commissioned shortly, that is at NTPC bar. And almost turbine wise also equally the matching components turbine is also almost 16 sets we are in various stages of the commissioning. And BHEL, as you are aware, in the past 50 years, all the power plant equipments are under one roof, be it boiler or turbine or condenser or motor, transformer, anything you name it, we are ready to with it, including control systems. And we have geared up to meet the huge capacity addition with the 20,000 megawatt capacity. And we almost made a replica of the chip plant. Phase 2 is ready just here. This is about our manufacturing preparedness. Thank you.
Very enlightening, Mr. Chandrasekhar. Thank you very much. Gives you. I think before we start the question, I just have a few points. You have touched the boiler area very well, but we would also like to have more information about your turbine so that as a complete, maybe it may not be today, but we can have subsequently from BHEL, and then we can pass on those information in our forthcoming issues.
Okay, so as 1 minute. As far as turbine is concerned, we have also given turbine up to 800 megawatt and 660 megawatt, almost 16 turbines equal to matching turbines we are supplying, and 800 megawatt we are giving in Gajimara we are giving, and 800 megawatt each turbine is also ready. Sir.
My question is, you said
I have restricted to coal because since we talked about coal, that is why we linked coal and boiler. Otherwise, we could have put a generic thing.
anyway, the heart of the whole system is anyway the boiler. The whole game is the boiler finally. Of
Yes,
course.
sir.
Main is boiler.
Yeah. Turbine is also critical, but I think boiler is more critical.
Turbine follows what boiler generates.
Right.
You know, one is the transmitter, other is the receiver.
Okay. Right, sir.
So, I have a question.
Yeah.
This 30% you said blending of coal,
Yeah.
So that is basically you're talking of with indigenous coal, blending of imported coal,
Yes, sir.
up to 30%.
Yeah.
But is that a limit, or you are trying to you will be able to experiment of more blending?
No, it all happened like this, sir. We have all our Indian power plants are designed for only Indian coal. We thought of introducing imported coal, smaller things. We experimented in plants like the Annum and other plants. We started with the 10% and 20%. They were very quite happy. And with that, we had a long correspondence with the CEA. Finally, it was decided all the new plants coming currently, which are using 100% Indian coal as the basic coal, must be capable of accepting 30% coal from imported coal. This is to tide over the coal shortage.
Okay.
That is the main thing. But virtually that unless you do a real perfect blending, it is not possible. What they generally do in most of the power plants is one bunker they put imported coal, other bunker they put Indian coals. Then it is trying to operate is somewhat difficult. You have to go for manual mode, operate with lower speed, the bunker, feeder speed of imported coal. We'll have to do it. That is, sir.
Yeah.
Pardon, sir? No. No GR fan, sir.
Okay, another thing you just said is, the older power plants now, they are taking about 12% up to maximum, they're able to accept only 12% imported coal, the current blending.
Yeah.
So that is the scenario. So will all those older plants, this is a question which I want to ask you, will they have to be shut down because now with this scenario?
Older means really a very difficult term, sir, because you take Singrauli, which was commissioned in 80 to 84, is doing very well. Right now, 500 megawatt is doing. Why should I disturb? It is giving a 500 megawatt just like that. I don't want to it.
No, but with this kind of pressure, more plants coming, both in the private and public sector, I would say even NTPC would expand, and I would say about 4 or 5 private players would have capacities. Will it be a scenario that the older inefficient plants finally will have to be done away with, or do we have an R&M program in this country?
We have an R&M program for life extension because the incremental benefit what you are going to get, maybe say for next 5 years, the amount of money invested is more than justified. That is why instead of going for totally new plant, where because of so much of uncertainties in coal and our money resources, most of the plants they go for small R&M but higher capacities.
Yeah, because in Maharashtra there has been experience,
Yes.
and the criticism is going on that so many plants were shut down by our
Yes.
MSCB at the time. And many of those plants could have come up, And it was because I didn't find any other reason other than the fact that a new plant costs about 4 or 5 crores per megawatt and an old one, renovation, will be only 2 crores, were not beneficial to some fellows politically.
Correct.
Beyond that, I don't see any reason why they were just shut out.
But for the huge investment, because otherwise the clearances are available. So it is, and again, as I told you, sir, right now it is going to be only supercritical. They will have to immediately go for minimum 660 megawatt. So if you are having 210 megawatt plant, 2 units, then they will have to think twice, because whether they have other facilities can take care. That is a problem. Because now virtually the subcritical market is closed. It is all this plant, it is going to be only supercritical. That is minimum is 660.
Professor, I have to tell you, R&M experience has been disastrous in the country so far. Wherever R&M work has been taken over, I mean, in the old plant is not performing at the earlier efficiency. So I don't know if the country is really equipped, unless we have a specific industry, a specific entrepreneurs coming up only with R&M expertise. And to combine R&M expertise with normal manufacturing expertise, it has not been a success in the country. Because, I mean, whichever case you take in the country, we don't have a single success case in the country as of now. Otherwise, at one time, I remember Minister of Power had envisaged about 50,000 megawatt addition to the capacity only through R&M.
It has
No,
taken back.
one more thing in this, I want to just ask you whether it is true. See, minus the NTPC Alstom, the joint venture for R&M renovation modernization, there was no specific effort to put up more number of such ventures. Specifically,
DHL Siemens.
DHL Siemens is not.
okay.
And it had to shut down. It had to shut down because it could not.
So now what was the reason it got shut down? So that is the question. See, because R&M could be a major factor, because unlike in hydro where we are not adding capacity and we have renovated plants to better capacity, the thermal thing is going like it's fizzling away. Huge amount of money is paid to those plants. We want to keep the tariff down, gain on efficiency by retrofitting and have an operator. So instead of building new capacity, this could be cheaper in the long run.
See, the margins of the mainline manufacturer are much higher in a fresh supply of equipment than in retrofit. Very, very honestly. But I'm telling you again that with the domestic experience, R&M has not been a success in the country. Because it so happened that their capacity has come down after R&M in so many projects.
I'll just tell you about the old plants. See, when you take the Russian plants, which are maximum in number because BHL did the maximum, so most of the points are
Only for Russian.
Russians. So 210 megawatt or 110 megawatt, so they're all Russians. Now, look at the heat rates and those plant heat rates and turbine heat rate of the boiler efficiency. If you wish to upgrade that, even if you do it by 10%, with similar heat rates, it's still not viable.
Certainly not possible.
It's not possible. So it's better to replace that
Shut it
and
off.
put it on
Shut
that.
it down because the overall, if you see the overall economic factors that will come in the final thing will be much higher than this R&M issue. Because of the carbon credits you will get new heat rate, better heat rate, very high heat rate rather, I would say, very low heat rate, and also how much you save on the coal.
What has happened with these issues is these plants, once they shut down, let's look at scenario of 30-year-old plant shutting down. Those plants remain like some kind of a dilapidated, building or something. I have nearby my place in Maharashtra, it's a small 50 megawatt thermal power plant of those days, done by railways. It is called the Thakurli Power House. And that thing is just lying there. You could put up a gas turbine station or do something there, and with no land bank in this country, I can imagine a scenario of doing away with so many plants and not doing anything with the resource.
So, Professor, we should take it up to REPA. We should take it up to REPA that wherever these have become non-viable, convert them to solar arrays. All of them. I mean, pull them down and use the area available to put solar arrays so that we have renewable energy with it.
So Bombay, what is happening is they're trying to convert it into a gas station. They're saying they can put up a 700 megawatt gas turbine power plant.
What is the gas?
And they're talking about it.
Unfortunately, what are we only talking about? We're talking about.
The government is going on doing this.
No, but
I told you 25,000 megawatt as of today are not having gas. They are just idle. 8,700 already commissioned and another almost 17,000 megawatt under commissioning, which is no gas.
no, but NTPC we have a different experience. Right? Like Talcher, Thribal and Tanda and Badarpur, all the three plants are more than 25, 30 years old and they are operating beyond 90% PLF. And the cost of generation is at par or maybe less than what you have from a newer capacity. So probably what has to be done is a proper RNM that is required to be done.
Is there any specific reason for the failures of this RNM? I think they have outlived their life and life expectancy is not possible.
For backward engineering is to be done for India. This is where I think also this popular. Not only the smaller turbine, we look at the big plant for the productivity. Even the smaller plants you have and including your change my pictures and the power composers are quite old.
That means
It's a complete revamp which you look at it to complete plan. You cannot do one part of the plant and say this can be revamped. This is total overall has to be built the plant and some where it's very old plant. Some of the re-engineering is required on this plant, which leads to go into lot of re-engineering is required compared to new plant for R&D. And NTPC plants are successful because NTPC has done a lot of re-engineering, so they have gone to R&D to further.
I think the RNM is not only replacing, even the design changes are to be done, steam path changes has to be done, and that's right. Then it is RNM is okay. Otherwise, it is just cutting one pipe and putting another kind of pipe.
You see, some of the CEF funds have been given to replace one part of the relay, replace a part of this. That's where this garden has gone in a bad shape to us.
But sir, when you design a plant for 25 years now, when you do all the financial modeling these days, you're doing it for 25 years.
Correct.
So after 25 years, the plant itself goes into
Zero.
Yes.
Value
There
zero.
is no point in
reviving that.
Exactly. Better to go for.
What's your new plan?
I think
Except your balance sheet will show because depreciation zero.
Zero.
Exactly.
So bottom line will go up.
No, but by R&M, your life, plant's life gets extended.
no, but it is what time you do the LES studies.
Yeah.
Not at the time of 20 years. You have to start doing it LES studies at 15 years.
Not in 20 years. They do it after 30, 25 years. By then it
It
becomes
should be
production.
not, rather the regular maintenance.
But then there are superpowers because they are really making some dead man alive.
Yeah, just, can I make some two issues related to R&M?
Yep.
See, one of the major reasons for failure of the R&M program is we have never been able to identify the right requirement, what exactly is required to be done. The analyses are being generated by the owners of the developers, and the total risk of R&M in terms of the efficiency parameters is being transferred to the contractor. So it is not the same. He cannot take the complete risk from the R&M studies conducted by the owner. There may be a lot of lacunae and flaws in what actually is conducted, what scope is identified. So this is one of the major flaws. It should be contracted so far. That is one of the major reasons. And of course, as you said, in some of the cases, it will involve definitely a lot of re-engineering where there have been some design deficiencies. So yeah, that is one of the things. Number three, the 25 years of life that you are talking, it is a notional life. It doesn't mean that after 25 years I'll throw the plant, like the civil plant. So they may continue to operate for another 25, 30 years, depending on the manner you have been operating the plants. So it's, these are the minimum design margins that you build in, and then the way you operate, it will give you extended life. Yeah, so these are some of the two, three important parameters for the R&M.
See,
So what-
motor car gets registered only for 15 years. You cannot re-register it. For 25 years, the maximum you can stretch. 25 years invariably is plus minus 10%, so it goes almost to 30%. But you cannot, it's not possible because the variable, you can't imagine, see, you're running the plant at 500 degrees centigrade, 600 degrees, 700 degrees with 170 ATA pressure, or in supercritical 220 ATA pressure. I mean, but the metallurgy is not that advanced in the world that it can really go up into.
no, but you look at the PPA plants in US, they are more than 60 years, 65 years old.
See, the way you have considered, I mean, consider design margins, the way you have taken those margins, that is also important, and the way you have operated the plants, that has got a bigger impact on the life of the plant.
Sir, it is like this, sir. If you take very old plants, maybe 30 years back, they were all 110 megawatt sets or 210. They operate on low operating cycle. Maybe maximum 130 atm is the pressure, turbine is that. Now we are talking about 250 bar. That means almost doubling the pressure. Obviously, that much improvement in wind cycle efficiency. Again, those temperatures were not higher. We are talking about 568, 596. Combined efficiency is much more higher. Again, even if you want to demolish 110 megawatt, if you want even demolish 310 megawatt, net is only 330. I cannot put even a single 660 megawatt. It is not viable. That is where the problem. That is why they trust.
I think I take this point on the US. In 1960s, late 60s, they had come out with the supercritical technology then. In late 90s, they went for the renovation modernization of those plants. And they have, not all were renovated and many orders were cancelled. When I was in Toshiba, we got maximum orders from US for renovating supercritical. But within 5 years, they were all cancelled because they realized you're spending much more money, the output is going to be not so much. Because you need to understand the technology development in a mechanical happens every 15 years. Now, if you still want to utilize that 30-year-old or 44-year-old technology to the latest technology, then you have to spend a lot of money. And if you don't change to latest technology, then you're compromising, you're just increasing somebody's life. But you're not really getting the output. But we say that you can't get the same heat rate or economics. So that's why they were cancelled.
Still, yet can be run after 30 years. If we run that, means you put the money, you get a new one.
And then you keep burning that much additional quantity of coal for every.
Now, that is the most important consideration.
But I think the well plan, 4,000 megawatt has already been identified for phasing out, complete phasing out.
Yeah, complete.
So there are, not viable to operate.
It has to be, and we know now even the many Chinese will also be phased out.
The latest one.
No, it's not that within 1 year in Korba the boiler had to be replaced.
Absolutely.
Then within 1.5 years the turbines in Yamunanagar are having problems.
Right.
SR is down, Santaldi was down.
Right.
So, the rest Sasan is yet to come, it's only hydro test so far.
No, but it has something to do with operations also. Plants can get buggered up with poor operations also.
Yes, no doubt.
Within 1 year, no.
No time. You have a boiler star mission then.
No, but I tell you, even your car engine doesn't open in 1 year.
No, but
If you open up a turbine
got operational problem.
and a boiler, that's it.
operational problem.
The Chinese are absolutely, I'm telling you,
It depends how the engine is being used. I mean, at the end of the day, if you're roughly managing
The
your
operational problem does not make the plant shut down for 2 months or 3 months.
no way. See, I have seen the Anpara design. I'm sorry, it is Lanco's plant. It is the most horrible boiler I have ever seen erected in my lifetime. Where I went. And that I think is already having problems.
I can also talk about Anpara because I erected one 2 into 500 megawatt Anpara B. And for 18 years the generator has not been opened.
Right.
And only for the last 18 years, one turbine has been overall. That is because of a water injection. Otherwise, it need not be open.
I fully support you because the boiler at half of the
Because I went to the site at that time, it was, Reliance had barely put up the chimney. And that is also, they had not even installed the chimney, they were basically doing the civil works.
So I think now we will request Mr. Rao to give his thoughts and his technology ideas on manufacturing.
Thank you, Arora sir, and thank you, Professor sir, for giving this opportunity for us to come here. I am Vijay Rao, working for NSS Astra Limited, a BS Group enterprise. We are into telecom, power, and into mineral resources. Basically, till now, we have been discussing about the coal reserves and the requirements, but I would like to discuss here regarding the quality analysis of coal in order to get the maximum output. The topic today is maximizing coal resources and generation output. When we consider coal as the most important factor, as more than around 65% of energy is based on thermal power on coal, if we can utilize the proper coal, a quality coal in this, we can get a better efficiency. At the same time, we can cut costs in different levels. The most important indicator for coal burning in power plants and heating plants is the specified, if possible, a constant quality and a constant calorific value of the supplied coal. If this is there, the efficiency level can be very high. It is very effective and economic to prepare coal of the required quality directly from the coal mines, or at least we can do the same thing in our coal plant operations itself. For doing all these things, basically we need to have some sort of instrumentation like an online ash meter or in-service ash meter of the laboratory model, automatic coal samplers, auger samplers, and besides all, there is a safety issue which we have to use this thermovision cameras also, along with the CCTV equipment. When we take into consideration the coal, few of the customers whom we have visited, they said the quality of the coal which we are getting in the Indian coal is approximately, the ash content is 35% ranging to 45%, whereas in imported coal it is approximately around 12%. The required efficiency for an effective combustion in the boiler is the ash content of 13 to 17%, which gives the real output. And in order to achieve this, most of the power plants today have been doing the coal homogenization of the Indian coal and the imported coal in the ratio of 70% Indian and 30% imported coal. And this is just like a standard now which is being followed, but whatever we are doing, are we sure really the coal is getting mixed properly when we are sending this through the conveyor belt to the boilers, and are we getting the right efficiency in the end? So for this, we have suggested. Yeah, we are discussing as per the instrumentation of what we are going to suggest is basically for the coal ash analysis and the GCV. Though the other parameters are there, the instrumentation of what we are suggesting from our end, we are going to discuss here now.
So is it going to reduce your testing time?
Definitely.
See, this is one area really where we have not advanced much in terms of technology.
Right.
It takes me 48 hours to get the value of CCV.
Exactly. I'm coming to the same point, sir. You can find the same thing in next slides of mine.
So that is going to have significant time?
Yes. And we are going to give the GCV value in 3 minutes time. That is a specialty of our equipment. And I'm coming to that now. The main application of this coal ash analyzers is like in coal excavations, coal cleaning plants, coal homogenization, coal sorting, power plants, cement industries, and all. Why we are talking about the coal excavation? At the time of excavation, if we have an online analyzer, we know from a particular seep, like what is the coal quality we are getting it. In the same mines, we get different qualities, and at least we will know that this particular seep gives this particular of quality of coal with this ash content. An online ash meter, like the one which we are suggesting, it is very simple and user-friendly in operation, and this analyzer does not affect any conveyor belt operations. There is no crushing of coal required, and there is no size limitation in this, as well as when you see even the life of this particular equipment to the source what we are using is approximately around 20 years time. The online ash meter is mounted directly on the conveyor belt, where we keep the source in the bottom of the conveyor belt and a sensor above it in the frame, and the data will be transferred to the control stage. And the basic principle of this, what we are using, is the radioactive element, americium and cesium, in the bare minimum levels, which are more safer than using an X-ray equipment in general. Usually, the first question which is going to come when we are talking about a radioactive is it safe? Definitely it is safe, and it is approved in CA. And this technology is available all over the world, and even in some parts of India also. But we are bringing this specific technology into Indian market for the first time, wherein we can assure you get the maximum mileage out of it. This is the schematic of the ash analyzer, where you can see the source is there based on down below the conveyor belt, and the rays are passed through to the controls detector stage, and from there it is going to the control, and from there it can be accessed to the server. From the server, anybody can access the data, whoever are authorized. And here we are going to give the quality and quantity of the coal which is being passed through the conveyor belt to the boiler at any given point of time. This is more important because the coal resources, whenever we are taking from the stockyard, we know at least this stock contains this ash percentage and this much of GCV, and accordingly we can assess what is the energy output coming out of it. Pardon me? Plus or minus 1% accuracy. Yes. And this will be, I'm coming into that, sir. Oh yeah, sure, definitely. So this will be the display, actually. The ash content percentage is mentioned there, and the calorific value of the coal passed through the conveyor belt on the given point of time, and what is the layer thickness which is passing through, and the tons per hour. The quality and quantity is being monitored on a real-time basis. Coming to the moisture content, we have a moisture meter integrated with the online ash meter, which gives even the online GCV. In the same similar sort grounds, like you get online ash content, online GCV in the real-time basis. This is like a coal quality management system. It is not just like if we install an ash analyzer that gives a solution for the problem, but if at all we have a total coal quality management system, starting from the mining level. This is one particular one which is done in Czech Republic. If we are able to do the coal quality at the mining level, from there when we are dumping into the stockyards, and when we are doing the coal homogenization, and after that when we are pumping it to the boiler section and to the burner. So in different levels, if we can follow this procedure in a systematic manner, definitely yes, we can show a very good improvement in the efficiency level, as well as can save a lot of money on burning the coal. These are some of the applications like coal yard homogenization, power station coal fields at the excavator levels. If at all these things can be followed on an online process, we know exactly what percentage of ash content coal we are getting it and what is the GCV value, and accordingly we dump into the stockyards and can be utilized better. Next one is an automatic coal sampler, which is installed near to the boiler, where through a rotary hand, a part of the sample is being pushed through the analysis part, wherein again an online ash meter keeps monitoring it every half hour, 1 hour, depending on whatever we are doing. Usually the manual process, they send the people to collect the samples every half hour, 1 hour, but nobody are sure whether the sample is collected in that half an hour, 1 hour. But the data is given like this is the sample and this is what the value is, but we are not sure. But with this sort of technology, yes, we can be sure of things like through the rotary sampler, we get the data, and through our online analyzer, this says, yes, in this particular time, we got this sort of mixture and with this ash content, and so this energy output is.
Why do you need the sampler when you are able to do on the bed?
Automatic coal sampler is again for process of authentication in the boiler level. You are doing a coal homogenization. No, sir. In some of the certifications, they do ask how many times are you sampling your things. If at all, when we are doing the sampling in the initial level, you need not collect the sample in the end level. But usually in the end level, end point, they collect the sample in order to give their certification saying that this is what we have proposed, we have mixed, and we have received it.
Nobody, the supplier never agrees for this kind of sampling. It is at the receiving end.
One thing, sir, we are not talking here about the supplier part. Here we are discussing about how better are we going to utilize the resources available with us.
That's what I'm asking. Why should I take this sampling again when I'm able to?
You need not do the sampling manually, sending the people, because you are not sure whether the person is going and collecting the sample every half hour from that particular point or the area. But here automatically it is done. It is just mechanized.
That's all. My simple point is,
Yeah.
if your sampler is able to take the digital measurement on the bias itself,
Yes.
what's the need to take sample again?
There is, yeah, I'll come to your point. In boilers, like there are suppose 2 coal fields in the particular conveyor belts in whatever we are sending. Everything is monitored initial level, in the middle level. It is not just at one point we monitor it. It all depends on our power plant, like how many analyzers are we going to use. In some of the power plants, if at all you are going to just use the online ash meter at the time of dumping into the coal stockyard, definitely you have to do the coal homogenization, where in the second level you should have one more analyzer to know whether we are doing the coal homogenization with the Indian and imported coal properly or not. Are we getting the right result? And then, suppose if at all there is a variation and they need to have a cross check in the general manner, right now they have been sending the people every half hour, 1 hour to collect the samples for a rechecking process. That is a standard norm which a power plant is following up. That's the reason we have made it like with an automatic coal sampler. The part of it is sent automatically. It need not be manual, only for that reason. The next one is the auger samplers. Auger sampler is also like for picking up the samples from the trucks or the wagons. Usually, if at all it is being done or taken mechanically, there is a chance of a manipulation or in a particular slot the coal is lifted. But here, this is done from any level, in any point. We can pick up the sample and then it can be processed through the online analyzer again instantly, saying that this is the value of the particular wagon carrying this coal. It's only for making things easy and more mechanical. Coming to the in-service ash meter, this gives the answer for your GCV analysis of what you're talking about, 48 hours. The general scenario today is the coal, when they are receiving in their power plants, definitely the stock is not sufficient to do the analysis and then burn it. The moment the coal is coming into the stockyard, it is immediately sent onto the conveyor belt to the burner. And by the time the analysis report comes, definitely there will be a variation in the energy output and the quantity used. That's where we suggest this in-service ash meter, which can be used on-site or even in the laboratory. The very simple process of this, there is no crushing required, there is no drying required, and there is no milling required as you do it in the general normal process in the bomb calorimeter. You can just pick up the sample in the prescribed format of what you take it and just dump it into the container what is given, and we place it into the system and shut it down into and the door is closed. 3 minutes, we get the data, what is the ash percentage and what is the calorific value. This will be the system in which the container is kept, and we are keeping the coal sample in the green one, and we are just closing the top shutter. The result of it is given on the touch screen. What is the ash percentage of it, and what is the calorific value, and what is the layer thickness, what is the amount of coal we have used for sampling. And this sampling process will take at the maximum 3 minutes to 10 minutes time, and now we have reduced it concretely to 3 minutes time. In the general normal process, if we go as per the bomb calorimeter, we have to do the drying, crushing, milling, and all those things, and then do the analysis where you are taking 48 hours, and by the time we get the result, we are totally consuming the coal. So this is one of the best ones, like the moment you get the stock, you can analyze then and there itself and know where to position your stock and how you can mix it in a better manner. Yeah. And coming to the safety point of it, one thing is the coal quality analysis, and the second thing is how better are we using the secured part of it. We have a thermovision system which has a thermovision image as well as a CCTV image, which monitors the coal stockyards as well as the coal conveyor belts. These are some of the pictures and how we are monitoring the coal stockyards. And this is how we monitor the conveyor belts. If you see the CCTV image and the thermovision image, and the thermovision image, you find orange spot, which there is a cigarette butt on it, but whereas you cannot find the same thing on the CCTV image. The moment the change in temperature is identified, automatically there will be an audio-visual alarm system in the control room in order to control this. And this really averts major accidents. On November 24th last year, there is an accident occurred in VTPS, Vijayawada Thermal Power Station, where 2 units of their underground conveyor belt systems are totally burnt because of this problem. Actually, it is not even the fire which made the accident happen, but because of the rollers heating up of the movement in the conveyor belt systems, the coal caught fire and the plant is shut down almost for a week's time. If you consider the amount of loss and if you see the technology, definitely this works out to be in a better manner. You can notice here the rollers are getting heated up, which can be identified only with the thermovision image and not with the naked eye or the CCTV image. Immediately the measures can be taken care. And the speed is not the limit for using this technology. And even in the smoke level, you can observe that it can be identified and the audiovisual alarm be given in the control room. And the same systems can be used for surveillance, fire protection, and all. And in the conclusion, like we say, online coal and ash analysis technology, once installed in the plants and in the coal mines, it gives the maximum mileage to us. And obtaining the GCV value of the coal in just 3 minutes time will be a major advantage in order to position ourselves of the coal we are using. And at the same time, if at all, like the analyzers along with the thermovision security systems, if we implement it, we can have a better way of handling our systems and the power plants. So above all, like there is one thing like YEL, NSS Astra Limited, we believe in teamwork and all hands join together in order to bring the technology out. This is a brief about our company's information, BS Group Enterprise. And we have 2 patents which we have already brought it into the market. And these are some of the business verticals of our company where the product lines, we are into the IDDs, intelligent data devices, like that. We are into the turnkey projects. We are into the power, telecom, and mineral resources and renewable energy. And our company is a TUA certified company. And with our strengths, we achieve our goals and the customer satisfaction in the simpler and easy manner. We know the route and we can show the route. And this is our contact information, and we'll be free and we'll be pleased to give any information required to anyone. Thank you all. And in the end note, I would just like to say, since we are talking about coal, my heartfelt thanks to one and all who is working in the coal mine, who is going deep inside into the darkness to give light to us. Thank you. Thanks all.
I think everybody talks about coal. We remember there used to be a slogan by the Coal India: carry with cash, not coal but ash. So I think because of that, people went out. Now the energy security people are talking about with import. Well, we thought about 10% import coal. Now we already reached 25%. The way we discussed in the morning, that if we need about 1300 million tons by 2022 and we have a capacity of 600 million tons to be produced in India, 50% has to come. Now that is going to be a major bottleneck, which means it will have impact on the generation capacity. So we'll have to look at alternative methods.
See, you have to see how Coal India improves its production. They are at a static, what invariably used to be called as Hindu growth of 3 to 4%. They are not
Yes.
keeping, they are not keeping, they are not matching the growth in the power generation sector, in power capacity addition sector.
You're
So
right.
problem is with the state enterprise that controls the mining of coal.
You're right. In 1990s, people used to say the 7% growth or 8% growth GDP, the elasticity was 1.1 on the power. So they reduced it to 1 now. With 9% growth, they say the elasticity is for the power growth is 1%. The way Coal India is going, we may be 3 and 4%. The power growth will also come down to 0.7. So with this, I think we'll request Mr. Murthy.
See, 85% PLF this time we are having about subcritical. See, let me tell you, what are you talking about 85%? Singrauli is operating 104%. 104% PLF, Singrauli, Talcher.
What is different in the sense, today in the country, none of our plants are operating at suboptimal level.
Suboptimal, yes.
Supposed to operate at 660, but maybe they are operating 550. So, let's say very, simple question I ask, if I am operating the plant at 85% PLF, definitely the return is the increase. The parameters will try to come down. Definitely it is loss in the wall. But in this case, maybe the temperature raises, it will be faster. So in this context, I am just asking, what is your assessment as of now? We have the data. At 85% PLF, what is the return to increase? The critical percentage or supercritical?
I think Shakil would like to respond.
Sir, as per supercritical point, we are not yet to commission. It will be the first thing. PLF wise, it will be, because PLF is because actual generation to ideal generation. Actual generation, if you take a 660 megawatt, you are operating at 500 megawatt means it is some other reason that posed to, possibly due to some disturbance in auxiliaries or some grid demand. Those things cannot be attributed to this point.
Purely based on SBD, if I ask you let's put it more technically,
Yeah.
what your SBD says, the heat balance diagram,
Yeah.
if I draw it 85% for subcritical and for supercritical, what is the difference?
If you talk about 80% load, 80% load you mean?
Yeah, I have to complete with load. At
80, okay. If it is between BMCR to 80% load, the temperature will be always maintained the rated value. Superheater is 568, reheater is 596. It will be maintained up to 60% of the load or even 50% load. So temperature is maintained. Then our pressure also, if at 660 megawatt at TMCR is 250 bar means the same is maintained at lower also. So the not much between BMCR to 80%, not an appreciable drop in, increase in heat rate is noticed. And
At the type of bidding, everybody takes about 80% load. What is the heat rate? What is the heat rate? 105%, 90%, 95%. So I think at this stage, nobody will remember what is the value of that. I think we can answer your question, but your question we can always answer. Because it's too early to talk about the derating on the supercritical. I think we can request our next speaker, Mr. Murthy, to say a few words and his knowledge about this power sector, what is happening in the last 20 years.
Good afternoon, everyone. Everybody has talked about the main critical points of boilers, generators, everybody has talked about. Let me talk about the BoPs. You see, when you have gone to the supercritical and ultra-supercritical, I think there are 4 points which needs to be seen, which is in terms of BoP, again, I'll say it's mechanical BoP and electrical BoP. And then there is automation, which is also very critical when you are going very high parameters of temperatures and pressures. And then comes, which has been also covered by TC RRG, construction equipments, construction methodology. And last but not least is the logistics. Because we are going for much bigger atoms. If I come to EBOP, it's a question of Srivasa Sabhi morning bola tha, it's 765 kV is already existing. And most of the ultra-critical power projects have to have a 765 kV substation at the generating end, and at the transmission and receiving end also it's going to be the same thing. And if you put too many projects, we may have to go to a 1200 level. So as far as this technology is concerned, the world technology is today available in India, we can say safely. Most of the world people, BHEL has already upgraded their technologies and they have tested some of their transformers already. Alstom T&D is in India already, which is Areva earlier. ABB has done it, Siemens has done it already, and Crompton Greaves is also doing this technology is available with them. So any component required for 765 kV is today can be manufactured, or I can call it sometimes assembled, because they get some of the parts imported as a kits, and it can be manufactured today in India and it's available in the Indian rupees, with of course a few imported components. So as far as electrical BOP is concerned, I think the Indian industry is geared up to meet the demands of whatever is projects which are lined up and which are coming up. That's one of the major things which can be safely set up. As far as mechanical BOP is concerned, I think there are certain concepts in this where we have some problems in some areas. Whereas circulating water pumps is concerned, I think technology is available and people are able to do it, like companies like Kirloskar are able to do this type of technology. Then comes, we talk about ash and coal handling plants. You see, most of the suppliers, if you look at it, ash and coal handling plants today, most of them are assembles. Nobody is manufacturing fully any ash or coal handling plants. They are buying components and they are doing the things. See, I think this area is also some of the people who are already working in this, they are having some tie-ups to have the higher capacity systems to be available for them. And I think they can meet these demands in India. Then comes automation is, I'll come into the next. Then water treatment plants. And water treatment plants, in principle, I don't find any much of a problem to be manufactured in India for whatever capacity it is required. That's the technology is available and people have that capacities. And all these mechanical also require what we call the contract manufacturing. Another thing which is a big chunk of business, I'll say, which is needed for any of this type of business is contract manufacturing. And the contract manufacturing for the mechanical equipments could be, in some areas, could be a little bottleneck. There may not be certain equipments available for doing the huge pieces of equipment which are to be done for these fabrications. This could be one of the things because our manufacturing setups for the small and medium level are not geared up to this level if you want to get anything done at that level. So that could be one of the major weaknesses, I'll say, in the whole supply chain management for this supercritical and ultra-critical projects which are going to come up. And this area is the one which needs hand-holding by these major companies who are working not only in terms of technology, also in terms of financial backups. I think they need a lot of hand-holding. I think this is the area which needs to be looked by the people who are working on this. And next is the logistics. This is, I think, most of the areas which normally I see most of the seminars. This is one area which is missing, whether it is hydro or whether it is thermal or whether it is nuclear. Logistics is one of the major issues in a country like India, which are because of our geography. We are so much far off distances, some of the areas. The roads are not fully developed. Some of the projects which are coming are remote areas where you don't have enough space to carry your hand equipments. I think one notion of logistics also needs some attention by the policymakers in terms of the infrastructure development, in terms of the roads and everything. And I think this area also needs to be seen by people. And automation is one area where I can tell you the automation has developed fully to meet to these demands, and most of the equipments and the most modern equipments are today available in India from all the major manufacturers in terms of Indian rupee payments. That's also another big developments and big changes have happened in control and measurement systems in automation, which is a huge potential for these projects and which will be one of the major business area for some of these major companies for the automation for these major projects. And in fact, when you are going to ultra and mega super power plants, the automation for even for the small ash handling, coal handling also become critical, which needs also to be controlled with your major central control systems. The integration of the whole automation systems also becomes another major thing. So I think these are some of the points which also needs to be considered when you are talking about the ultra mega and supercritical power projects, in addition to what we are talking about the core technology of boilers and turbines. So many people have talked about boilers and turbines, so I thought I'll point out these points which can be seen in terms of requirements. It maybe looks like an auxiliary for a plant, but at the same time they are becoming more critical. In terms of transmission, I think the country needs to speed up its transmission lines in terms of the requirements of the projects which are coming up. I think still there's a lag between generation and transmission and distribution. And still, I am also one of the advocates with whom I feel decentralized power supply is the answer for this country for most of the places. Industry needs the big ones, and households needs the decentralized power supplies. Thank you. Thank you.
Thank you, Mr. Bhuti. I think we had good views from every one of us, and maybe the last word from
Wind up is the last word.
Good shot. Good shot.
Well, I think you can say from here.
Yeah. What I said, wind up is the last word. Friends, since morning we are hearing all these things, call and policies and making up technicalities and capacities and manufacturings and all the things. Today, what we seen that we are today somewhere around 200 gigawatts, and in thermal what we were talking is 120 gigawatts somewhere, and that is after 65 years. And now in coming 5 years we are thinking 75 gigawatt. It's a huge task. But what Ashwini has told, or the other panelists told, it is possible because today we have a capacity of 40 gigawatts installed in our country, private and public both, what you say is. So possibilities are there. But the basic thing is, if there is an input, there will be output. That is the law of nature. So what input we will be having? All intellectual people are sitting here and discussing, but the real input is in parliament, not here. Are they going to give proper input? Are the policy makers going to give the proper inputs? If they are giving proper input, we will get proper output. Less losses. So the efficiency is to be considered. If we will talk efficiency, again we were talking here manufacturing. Let me say, give you one example, manufacturing efficiencies. If I want to produce one piece, then if I'm supposed to give it to Japan, they will use 1 unit to produce this. If I'll give it to USA, they will say they will be using 1.4 unit to produce it, while India is using 2 units. So efficiency is to be improved again. For manufacturing this one item, if we are going to use 2 units and Japan is using 1 unit, so basically India is governed by the people. Here all the industries are governed by the humans rather than systems. So focus what we are, if we want to achieve, the system has to work. Even in parliament, it is governed by the people, not by the systems. That's all from me. Thank you.
Thank you. Thank you, Mr. Yadav.
Just like to elaborate on what Mr. Bhuti said about logistics. The logistics nightmare in this country, I think, is understood.
Understood. That's what is the main thing. Yes,
I'll tell you my own experience. We were doing gas turbine, 200 megawatt gas plus minus 500 kV project. HVDC transformer weighs about
550 tons.
550 tons. And it's a complete nightmare to move that transformer from a place, from our Bhopal plant to the one of the terminals which is in Balia. There is no way we could move it. We had to get a transformer from Siemens, Germany to Bombay, take it across the ocean to Calcutta, bring it along the Ganges up to some point in Allahabad and then take it to Balia. Imagine from Germany it had to be brought like this too, but it could not be transported from Bhopal to Balia.
In fact, Sasaram we have brought the same way from Calcutta to Ganges, almost to the Sasaram nearby, another 5 kilometers only by road. That took us 2 days to cover the 5 kilometers because we had to cross to radio crossing.
So I think this kind of neglect, not just neglect is an understatement. Our people have been criminally neglecting, and I would very respectfully urge none of this neglect is because of CAG. It's complete paralysis as far as infrastructure, especially our transport infrastructure is concerned. And transport infrastructure has a very, very strong bearing on the power sector.
I think
basically the plant size has gone up, but not the infrastructure in that way has been developed. Plant size, like say refinery, fertilizer capacities are going 2.5 million ton. Now basic refinery size is 9 million ton. The equipment size has gone up, weight has gone up. So infrastructure has not been created for suitable to that size
No,
of
sir,
mega plants.
that is going too far. Infrastructure has not been created for even driving a Honda City from here to Dehradun. Forget about. So, I mean, this is the pathetic, criminally pathetic state of.
Mr. Srinivasan, the point is well taken. But if the technocrats or the people who are going to do the siting, they are aware of for a 660 or 800 megawatt, what is the size and weight of the equipment. So why you select a site where you have this transport problem?
No, sir. I'll beg to disagree with you. There would be, then you would be left with very, very few sites only according along NHA that you can put a bug.
See, this is another area actually needs to be highlighted very well.
No, at least you partly answer my question. You may not agree, but you partly answer that yes, the siting should be along the NHA. So basically, I'm saying the siting should be done in a proper way.
The whole country can't be around NHA.
No, it's not a question of when you understand either the siting or survey which has been done before the plant even is taken up. The survey, route survey must be done.
I see
if
that,
the route survey is not done.
I see that India Bulls Act, it very well reflects that because the thermal power plant right in the middle of the city. See that television ad? You remember that? India Bulls TV ad.
Who is doing
But that's
Actually, I don't like that ad.
No, that's a bull. I mean, bull can go anywhere.
Absolutely.
No, the problem is, for all the projects, the route survey when they do it, I have seen the route surveys what has been provided by the people. The route surveys are just for eyewash to get the project fixed.
Same thing happened for the hydro. That's why we have.
Yeah, absolutely. You're right.
Exactly.
I do also say
You will agree that most of our power potential is in the northeast.
yes.
And there is no
Transportation is the
No transportation.
No infrastructure.
Sir, you recall that 660 megawatt generator
Sipper.
was stuck up in Konkan Hills for 9 months.
For the SIPL.
The
Yeah,
600
that's
megawatt
Sipper.
generator
Sipper.
on its way to
Sipper.
Chennai. It was crossing a bridge in Indore. It was a 370 ton stator.
Yes.
Bridge collapsed.
I think we have to change certain route. The parliament should have engineers and we should become politicians.
Now that I agree.
That should be theme of the next plan.
No, that's not very far from the truth because
Yeah.
lot of these equivalent of parliamentarians in China are actually technocrats.
Technocrats, you're right.
That's
In China, there is technocrats.
So I think we would like to close the session. We had in the morning.
Things from China? At least one better thing you can.
So we had a really fruitful discussion in the morning session when the house was full. But now after the lunch, many people felt sleepy. They left. Some people are
I
very
call it the
brave.
Delhi effect.
Huh?
I call it the Delhi effect.
Delhi effect.
Delhi effect.
Delhi effect.
It was हर बार ही होता है ना.
Well, even I could see some people were also naive anyway.
I know.
So it happens, so it's okay. But we would exchange our views on the manufacturing, we could exchange our views on the coal and other issues on the policy. But I think we have to really redefine the definition of market, the definition of competitiveness, and then the definition of regulations. So until as we really introspect these things on the definitions at least, so that people understand what is a market. Now generation capacity, there is a market. Coal is not there. Transmission is not there. Distribution is not there. So what is the market for power sector? I wish the generators could store the electricity in kit bags and give it to the consumers. And then it was the market. Now coming to the regulations, the regulation we have only on the power regulator, and that is only giving advisory. The state regulator don't care what the central regulator is doing, because it's a co-current issue. So that has to be really seen how it is to be. And the internet, also not the network of intrastate and interstate is so messed up, only those people know. All the linemen people know where the wire is going, where it's coming. So that has to be also really looked into. Third thing on the we have to say is the raw materials, the coal, the construction agencies, or even on the balance of plant for that matter. I will still repeat that you have a shirt without the button and you have a trouser without the zip. Now, if you have a steam generator and you have a turbine and you don't have balance of plant or coal, you really can't compete. So that sense we need to really look back where we went wrong and let us correct it. Thank you so much.
We have some small mementos that has to be given. Can I get the mementos? May I request Sumanji, once again I will trouble you a little bit. Token of appreciation for all our speakers. Yeah. Please. I think first we should give to Mr. S. Chandrasekharan, who has come all the way from Trichy. Thank you, sir, once again. For Hetalbai, he has come all the way from Gujarat, Surat. Another one for Mr. PVSN Murthy. Please give a big hand. One for our friend Mr. Rao from NRSS. May I also request, I will request Bhatnagar Sahab to come, and we are very thankful for him that he shared his time here. You know, he has come all the way up, and I have had many personal meetings also with him. Please, sir, come over from this. Ashwini Darji, that is the best way.
From my
Photo op.
I owe my existence to two Bhatnagars. Bhatnagar got me to State Bihar, second Bhatnagar threw me out of State. In that capacity, I am sitting here. God bless you.
Thank you, sir. Thank you. And I think we close for the day, and it was a wonderful time. I must thank everybody who has taken time off today and had a lively discussion. But all of us, we have a 1 month, we normally do that, 1 month time to return back to us with any ideas that you have will be included in that white paper document. We'll take a month more after that to just bring a draft, and then we are going forward with what plagues our thermal power sector. We need to achieve more than that. This is just it is just not sufficient, because if China can add 70 gigawatt every year, so I think 30 is definitely reasonable what TC was saying. I think that's the right way to do things, you know. Thanks everybody. See you again.